के कुछ और रहस्यों से पर्दा उठाने और वैज्ञानिक तकनीक का प्रदर्शन करने। तो बने रहिए हमारे साथ आज के इस मिशन में, जिसका नाम है PSLV C57 आदित्य एल1 मिशन।
Namaste viewers. The Indian Space Research Organization is gearing for its rendezvous with the sun. To take you along on the live telecast of this momentous event today, I am Madhuri, giving the commentary in English. With me is my co-commentator, Shivikas Swarnkar, who will be giving the commentary in Hindi. We are about to script yet another chapter in the glorious space research history of India. Today, the workhorse rocket PSLV C57 will carry Aditya L1, the solar observatory of India, to be placed at a vantage point from where it will be able to continuously observe the sun and while being in the visibility of Earth-based ground stations. 10 days ago, India became the first country in the world to safely land a spacecraft in the South Polar regions on the moon. I'm sure many of you were the eager and proud spectators of the Chandrayaan-3 landing that was being telecast from ISRO, situated in Bengaluru.
Roger.
We bring to you an integration film for the PSLV C57 that took place in Satish Dhawan Space Center, Shar, Sriharikota.
अभी आप अपने स्क्रीन पर देख रहे हैं, यह है प्रथम कोर चरण S139 बूस्टर का नोजल एंड सेगमेंट। इस प्रथम चरण के साथ ये शुरुआत होती है और यह मिडिल सेगमेंट को इसके ऊपर संयोजित किया जा रहा है। ऐसे 3 मिडिल सेगमेंट इसके ऊपर संयोजित किए जाएंगे और अंत में हेड एंड सेगमेंट सबसे ऊपर की ओर संयोजित किया जाएगा। और इस तरह तैयार होता है PSLV का प्रथम चरण कोर बूस्टर S139। इसमें 139 टन का प्रणोदक होता है और यह इग्नाइटर है जो इसे प्रज्वलित करता है। इस मिशन पे यह है PSLV C57 एक्सेल मिशन। तो इसमें हैं 6 स्ट्रेपॉन बूस्टर्स, हर एक में 12 टन के नोदक भरे जाते हैं। यह सब ठोस नोदक पर आधारित हैं। यह SITVC टैंक को उठाकर इसके साथ संयोजित किया जा रहा है। इंटर स्टेज आप देख रहे हैं, इसमें रिट्रो मोटर्स लगे हुए हैं पृथक्कन के लिए। और यह है द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है। इसमें विकास इंजन लगा हुआ है।
And here is the second stage of the PSLV rocket, prepared in the subsystem preparation facility and brought to the vehicle assembly building of the second launch pad to be integrated on the first stage of the rocket. Here you can see the third stage PS3 and PSO being moduled.
Roger.
And placed inside the respective shroud and then handled together.
Roger.
To be moved to the vehicle assembly building.
यह नज़ारा आप देख रहे हैं व्हीकल असेंबली बिल्डिंग का, जहां पर पूरे व्हीकल को असेंबल किया जाता है।
These are the visuals from the clean room of the spacecraft preparation facility. This is the Aditya L1 spacecraft being prepared and ensconced into a protective container where the environment is controlled and the temperature is controlled, the cleanliness is controlled. At the vehicle assembly building, again, there is a clean room provision to safely integrate it to the rocket, and then the heat shield halves are closed. Now the vehicle is fully ready to be moved to the launch pad, which is about 900 meters away. This is PSLV C57, standing majestically.
अभी आपने देखा PSLV C57 का इंटीग्रेशन वीडियो। यह पूरी तरह तैयार और कुछ अंतिम गतिविधियां जारी हैं, अंतिम जांच जारी हैं प्रमोशन से पहले की।
We are bringing this telecast to you live from the Mission Control Center at Satish Dhawan Space Center, Shar, Sriharikota. The launch will take place today, the 2nd of September 2023 at 11:50 hours Indian time from the second launch pad.
All stations switch over to channel 2 at T-.
The PSLV C-57 in its XL version will carry Aditya L1 spacecraft having a mass of 1,480 kilograms. The mission intends to place the spacecraft in 235 by 19,500 kilometers orbit with an inclination of 19.2 degrees. The total mission duration will be 3,799 seconds or 63 minutes 19 seconds. Apart from Doordarshan, you can watch the live telecast on ISRO website, YouTube, Facebook and Twitter.
अब हम प्रमोशन से 22 मिनट की दूरी पर हैं। आदित्य L1 सूर्य का अध्ययन करने वाला पहला अंतरिक्ष आधारित भारतीय मिशन है। इस मिशन से आदित्य L1 नामक अंतरिक्ष यान को सूर्य पृथ्वी प्रणाली में लैग्रेंज 1 पॉइंट के चारों ओर एक प्रभामंडल कक्षा में स्थापित किया जाएगा। यह लैग्रेंज पॉइंट पृथ्वी से लगभग 15 लाख किलोमीटर दूर है। इस तरह L1 पर रखे गए उपग्रह को सूर्य को बिना किसी आच्छादन या ग्रहण के लगातार देखा जा सकता है। यह अंतरिक्ष यान विद्युत चुंबकीय और कण चुंबकीय क्षेत्र सूचकांकों का उपयोग करके फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के सबसे बाहरी परत, जिसे हम कोरोना के नाम से जानते हैं, इनका निरीक्षण करने के लिए इसमें 7 निदभार लगे हुए हैं। इनमें से 4 निदभार सीधे सूर्य की गतिकी का अध्ययन करेंगे तथा अन्य 3 निदभार L1 बिंदु पर कणों और क्षेत्रों का यथास्थिति अध्ययन करेंगे। इस तरह आदित्य L1 उपग्रह के निदभार कोरोनल तापन, कोरोनल मास इजेक्शन, प्री फ्लेयर और फ्लेयर गतिविधियों और उनकी विशेषताओं और अंतरिक्ष मौसम की गतिशीलता को समझने के लिए अत्यधिक महत्वपूर्ण जानकारी प्रदान करेंगे। अब आपके सामने प्रस्तुत है आदित्य L1 कर्टेन रेजर।
The PSLV C-57 is prepared to launch the 1,480 kg Aditya L1 spacecraft into Earth-bound orbit, from which it will be placed into a halo orbit around the L1 point in 4 months. The satellite is intended to study the Sun and how it impacts the heliosphere. The Sun, which is the center of our solar system and has always fascinated humans, is a ball of hot gases formed by the nuclear fusion process. The visible outer surface of the Sun is known as the photosphere, followed by the chromosphere and then the corona. After initially dropping through the chromosphere, the Sun's temperature abruptly rises in the corona, reaching extremely high values of 1 to 3 million Kelvin. The Aditya L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Aditya Solar Wind Particle Experiment, ASPEX, and Plasma Analyzer Package for Aditya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the High Energy L1 Orbiting X-ray Spectrometer, HELIOS, analyze X-ray flares from the Sun over a wide energy range. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. Aditya L1 is equipped to take in situ measurements of charged particles and fields at L1 and is dedicated to studying the Sun across several energy bands. The Lagrange point L1 is located around 1.5 million kilometers from the Earth between the Sun and the Earth.
18 minutes and counting.
These observations are best made from a vantage point that provides a continuous view of the Sun. All payloads are designed in close coordination with ISRO centers and national laboratories like as IIA, IUCAA and PRL. With this mission, ISRO will once again demonstrate its position in space exploration.
We are 17 minutes, 23 seconds from the launch time. The countdown for PSLV C-57 Aditya L1 mission has been 24 hours long. It had started yesterday. During the countdown, critical activities have been carried out on the launch vehicle and the spacecraft. The propellant have been serviced into the launch vehicle stages. The bottles storing the gases for command and control operations have been charged to pre-launch pressure levels.
Roger. Control
The
to
onboard
LCC2
batteries
and
have
VLCC.
been charged.
Timing confirmed external hold mode.
LCC, Roger.
Now, in a little while, we'll go to the automatic launch sequence initiation, for which the preparations are underway in the launch and mission control centers.
ROD to Mission Director. Range is ready for PSLV C-57 Aditya L1 mission.
Mission Director Roger. TTC Director to Mission Director. All TTC Director confirms readiness of all ISRAC stations and network for supporting
अभी आपने सुना
C-57 Aditya L1 mission.
Mission Director Roger.
उपग्रह निदेशक,
TCTC,
रेंज निदेशक,
data loggers of
टेलीमेट्री,
Sharp 1,
टेलीकमांड
Sharp 2
निदेशक
station.
तथा यान निदेशक
TCTC
ने
corporate.
अपने तंत्रों की सूचना मिशन निदेशक को दे दी है. इसके पश्चात
T-minus 16 minutes and
सभी
counting.
आंकड़े संतोषजनक होने पर
Mission Director, Mission Readiness Review and Launch Authorization Board have already given clearance for proceeding with the countdown and launch of PSLV C-57 Aditya L1 mission. All operations in the countdown sequence till automatic launch sequence have been completed satisfactorily. Based on the clearance obtained from launch vehicle, spacecraft, range and ISRAC network stations and prevailing favorable weather conditions, Mission Director hereby authorizes to initiate launch operation sequence for the launch of PSLV C-57 Aditya L1 mission at 11:50 hours IST today, that is 2nd September 2023.
All stations to note, Mission Director has given authorization for the launch of PSLV C-57 Aditya L1 mission.
SDS servers activated. MC
अभी
confirms
आपने
data
देखा
from SHAR-1
इस
and
मिशन
SHAR-2.
के मिशन डायरेक्टर श्री
T-minus
SR
15
बीजू ने
minutes and counting.
इस मिशन का
Hereby authorizes to initiate automatic launch sequence for the launch of PSLV C-57 Aditya L1 mission.
Automatic launch sequence initiated for PSLV C-57 Aditya L1 mission.
The automatic launch sequence, the initiation has been announced, and hereafter a very critical capsule of performance validation for the launch vehicle systems will be carried out, and very close to the launch time, control will be passed on to the onboard computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस चालू हो चुका है. ALS शुरू होने के पश्चात रॉकेट स्वचालित होकर सर्वप्रथम T-0.3 सेकेंड्स पर RCT का प्रज्वलन शुरू करेगा और T0 पर कोर बूस्टर S139 का प्रज्वलन शुरू होगा. लेकिन इस दौरान वह स्वचालित तरीके से सभी जांच जारी रखे हुए है.
PS2 control system, redundant chain actuator in progress.
On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh. This mission is the 91st launch mission of ISRO and 59th of Workhorse PSLV. As mentioned earlier, PSLV's XL version with 6 strap-on motors alongside the core S139 motor is being used for the present mission. This is the 25th time PSLV-XL is getting ready for launch. So far in the year 2023, ISRO has launched SSLV's maiden successful mission, 2 commercial missions of PSLV, 1 mission of GSLV carrying the first among the second generation of navigation satellites, 1 commercial mission of LVM-3 and another mission of LVM-3 again carrying the prestigious Chandrayaan-3 spacecraft.
PS4 control system actuation in progress.
आदित्य L1 जो कि एक अंतरिक्षयान है इस मिशन का, इसको पृथ्वी से 235 बाई 19,500 किलोमीटर की निम्न भूकक्षा में 19.2 डिग्री के झुकाव के साथ अंतक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ पेरिजी 346.6 डिग्री को प्राप्त करने के लिए PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर इसे प्राप्त किया जाएगा। आर्ग्यूमेंट ऑफ पेरिजी असेंडिंग मोड और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ मापा जाता है। आदित्य L1 के इस दीर्घाकार कक्षा में अंतक्षेपण के पश्चात उचित समय पर और उचित अभिवृत्ति में अंतरिक्षयान में लगे लिक्विड एपोजी मोटर्स को फायर कर कक्षांतरण किया जाएगा और इस तरह 5वीं बार में LAM मोटर को फायर कर यान को पृथ्वी की प्रभावी क्षेत्र से बाहर निकलने में समुचित गति प्राप्त की जाएगी। फिर वह पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा और ऐसा करते हुए यह करीब 125 दिनों का समय लगेगा। 125 दिनों बाद यह L1 पॉइंट के पास पहुंचकर और उसकी परिक्रमा करना शुरू कर देगा और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा। अब हम उड़ान से 11 मिनट की दूरी पर
कंट्रोल सिस्टम एक्चुएशन इन प्रोग्रेस।
Let me in the meantime tell the viewers about the flight events that the launch of PSLV C-57 Aditya L1 will take. This mission is among the longest flights of PSLV. It is going to last for 63 minutes and 19 seconds. The liftoff coincides with the ignition of core S-139 solid rocket motor and the ignition of the 4 ground-lit strap-ons. While the rocket is at 2.7 kilometers altitude, the 2 air-lit strap-ons also commence their operation. The action time of strap-on motors is 70 seconds and the ground-lit and air-lit strap-ons are separated from the ongoing launch vehicle at 70 and 92 seconds into the flight, respectively. The core S-139 motor continues to thrust till 110 seconds. Since the second stage of PSLV operates on pressure-fed liquid engine, the optimal performance of the engine is ensured if the effect thrust cutoff or separation of the lower stage is countered by additional means of thrust generation. Therefore, the alleged motors provided for this purpose ignite 3 seconds before the first stage separation and continue to thrust for 11 seconds. The second stage, PS2, commences its operation 200 milliseconds after the separation of first stage. By this time, the rocket would have attained 55 kilometers altitude. The closed-loop guidance is initiated, which compares the present state of rocket to the intended injection point to compute an optimal trajectory. This happens while the rocket is at 59.7 kilometers altitude. At 204 seconds into the flight, the payload fairing is separated as the launch vehicle attains 113 kilometers altitude and the dense atmosphere is no longer present around. These events are taking place in the operational regime of the second stage, which lasts for 153 seconds. PS2 is separated 262.4 seconds into the flight at an altitude of 130 kilometers, while the relative velocity is 4.9 kilometers per second. The third stage, PS3, ignites about a second later and burns for 118 seconds, during which time it adds 12 kilometers to the altitude and enhances relative velocity tremendously from 4.9 kilometers per second to 7.3 kilometers per second. There's a coast phase of 200 seconds that follow PS3 burnout, during which there is no thrust being developed, but the rocket continues to be steered. At 581 seconds into the flight, the PS3 separates, and the last and the fourth stage of the rocket, together with the Aditya L1 spacecraft, coasts for a long, long time thereafter. Till 1396 seconds into flight, the tracking stations at Shar, Port Blair, Brunei and back will be acquiring the real-time performance data of the flight. But thereafter, there is no visibility period of around 1600 seconds or 27 minutes. The fourth stage burns twice. First time for a duration of 30 seconds and second time for a duration of 472 seconds. The first burn takes place in no visibility zone, and the second burn is tracked by a shipborne terminal placed in Pacific Ocean. About 200 seconds after the completion of second burn of PS4, the injection conditions for the separation of Aditya L1 are expected to be achieved. An altitude of 648.7 kilometers and a relative velocity of 8.9 kilometers per second, which translates into an orbit of 235 by 19,500 kilometers. The injection event of Aditya L1 will be confirmed by tracking station at Kourou. From the initial placement in low Earth orbit, Aditya L1 will undergo a series of earthbound orbit raising, and eventually it will exit Earth's sphere of influence to reach Lagrange's point L1 in a journey spanning over 4 months. There it will be placed in a halo orbit around L1. This is how India's first observatory class space-based solar mission will take shape.
Vehicle is in internal battery power.
अब हम उड़ान से 6 मिनट की दूरी पर हैं। ALS जारी है। सभी जांच सुचारू रूप से जारी हैं। इस दौरान यहाँ उपस्थित आप देखिए, यहाँ
External power supplies are withdrawn.
व्यूअर्स गैलरी पे, लॉन्च व्यू गैलरी पे उपस्थित जन आक्रोश, इनका रोमांच देखते ही बनता है। इतनी मौसम यहाँ लगभग 37 डिग्री का टेम्परेचर है, वायु गति 0.8 मीटर पर सेकेंड। इन सब के बावजूद यहाँ उपस्थित हुए हैं इस रोमांच को देखने के लिए। एयर ट्रैफिक कंट्रोलर और मौसम विभाग की अनुमति भी प्राप्त की जा चुकी है। विभिन्न ऊंचाई पर वायु गति माप ली गई है और इसे ऑनबोर्ड कंप्यूटर पर लोड कर दिया गया है।
The Satish Dhawan Space Center has its own meteorology department which keeps a very close watch on the weather at the launch base. Weather today is going to be dry and hot. The skies will remain clear. Ground winds will be benign and upper winds also are benign for the flight of PSLV C-57 Aditya L1 mission. We are 4 minutes, 23 seconds to the launch.
सभी वैज्ञानिक अपने कंसोल पर आंकड़े देखते हुए सभी तंत्र सामान्य निष्पादन कर रहे हैं। अब हम 4 मिनट की दूरी पर हैं उड़ान से।
T-4 minutes and counting.
सामान्यतः PSLV के मिशन लगभग 2000 सेकेंड में प्राप्त कर लिए जाते हैं, लेकिन यह मिशन कुछ अलग है। इस मिशन में PSLV के चतुर्थ चरण यानी PS4 को 2 बार में प्रज्वलित कर यह उद्दिष्ट कक्षा प्राप्त की जाएगी। इसका मतलब PS4 को प्रथम कोस्टिंग फेज के बाद प्रज्वलित किया जाएगा, फिर 30 सेकेंड प्रज्वलित रहकर यह बंद हो जाएगा, फिर करीब 1600 सेकेंड की कोस्टिंग फेज जारी रहेगी। तत्पश्चात फिर से PS4 को प्रज्वलित कर 472 सेकेंड तक प्रणोद उत्पन्न किया जाएगा और फिर शांत हो जाएगा। आदित्य L1 के कक्षा की स्थिति प्राप्त होते ही उसे निर्दिष्ट कक्षा में अंतर्क्षेपित किया जाएगा। इस तरह पूरे मिशन में लगभग 3800 सेकंड का समय लगेगा।
T-3 minutes and counting.
यह PSLV C57 का प्रमोशन यान ट्रैकिंग के संदर्भ में भी काफ़ी जटिल है। इसे ट्रैक करने के लिए शॉर, पोर्ट ब्लेयर, ब्रूने और बैग स्थित ग्राउंड स्टेशन हमें वास्तविक समय पे यान की जानकारी उपलब्ध कराते रहेंगे। लेकिन चतुर्थ चरण के प्रज्वलन के समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा, इसलिए शिपबोर्न ट्रैकिंग या शिपबोर्न टर्मिनल को दक्षिणी पैसिफिक महासागर में स्थित किया गया है। वह हमें PS4 बर्न 1 और बर्न 2 की जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और आदित्य L1 के अंतक्षेपण की पुष्टि कुरू फ्रेंच गयाना स्थित ग्राउंड स्टेशन से की जाएगी।
T-2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकंड की दूरी पर। यह PSLV की 59वीं उड़ान होगी और इस PSLV एक्सेल संस्करण में यह 25वीं उड़ान है। इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान 1 और मार्स ऑर्बिटर मिशन उल्लेखनीय हैं। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में 3रा मिशन है।
All stations stand by for the time mark. T-1 minute and counting. Minus 55 seconds.
All subs are armed.
Minus 50 seconds.
All sequencers armed.
तो हमारे साथ बने रहिए। अब 40 सेकंड पर
Minus 40 seconds.
प्रमोशन किया जाएगा।
VHPP open.
Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds.
PS2 VSPP open.
Minus 20 seconds.
PS1 ignition RMS arm.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
PT tracking.
Magnificent lift-off of PSLV C57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के
Plus
तेज से
25
विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही
Plus
एक और
30
कदम
seconds.
है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C57। प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky.
Engine main auto.
A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage, S139.
Ground lead strap on separated.
जैसा कि निर्धारित है, ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है
Performance normal.
और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground-lit and air-lit strap-ons have been separated. S139 motor still thrusting.
S139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
+2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation, and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
+3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated. Third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर। और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
+5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं, PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का। वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV C57 का।
For the present mission, after PS3 completes its burn duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
unique to this mission, the
Vehicle
PS4
performance normal.
will start twice at predesignated times
Plus
and
7
duration.
minutes.
The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3, PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravati Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth, the explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting. It is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक
Vehicle
पृथक कर दिया
performance
गया है
normal.
और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लियोनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature, which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrange point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere, and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle, and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer, or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope, SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE, and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer, or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short, PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer, or MAG, developed by LEOS, which will measure the low-intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप, जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX, सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है, जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है, जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य एल1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजुअल एमिशन लाइन क्रोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR राव सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India's made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripathi, PI of SUIT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the principal scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important, and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor UR Rao, along with Dr. Sri Kumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations, as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology, as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we'll move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L1 is a multi-wavelength, multi-instrument, and multi-directional mission. Multi-wavelength because it works in X-rays, UV, and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction, but also around it. Now, when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the Earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the Earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the Earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the Earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7 through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Yeah, so good afternoon. My voice is going to mumble because I'm still in the awe of the launch, and one of the payload is gone there. So Essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Anna Purnisubramanian alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, SOOT is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero, basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also, this sun is plasma. Now, when we are talking about the heliosphere, actually, with this, all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now, Dr. Bibin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha